All right, ladies and gentlemen, we're going to talk about section 8.4 today, which is about applying exponent properties involving quotients. There are two rules we're going to look at. One we've looked at before, and one's a little bit new. The first one, quotient of power properties. We're going to let A be a non-zero real number, and let M and N be positive integers, such that M is greater than N. To divide the powers having the same base, subtract the exponents. So like the funky little thing that it says on your paper, we've got A to the M over A to the N, which equals A M minus N. Okay? As long as A is not 0. So all that means is if you have the same base, you subtract the exponents. And then you solve. Okay? So the other rule we're going to use is the quotient of power properties, which is lower down on your paper. Let A and B be real numbers with B not a 0, and let M be a positive integer. So it's kind of like the distributive property again. We've got A over B in parentheses to the nth power, so we take A to the nth over B to the nth. Okay. So let's do some examples first of that first quotient. Okay? You need to scratch off the first part because there's a mistake on yours. All it should say for A is A to the 10th over A to the 4th. All right. So if we have 8 to the 10th over 8 to the 4th, the bases are the same. So now I'm going to go 8 to the 10th minus the 4th. 10 minus 4 gives me 8 to the 6th. But I'm not finished because that is a number, not a letter, right? So I'm going to stick it in my calculator. I'm going to go 8 to the 6th gives me 262,144. So that is 262,144. That is my final answer for A. So let's try B. B. I've got negative 3 to the 9th over negative 3 to the 3rd. So Melissa, what am I going to do?
Negative 3, 9 minus 3.
And what's 9 minus 3?
6.
So I get negative 3 to the 6th. So you can go ahead and put this in your calculator. Negative 3 to the 6th power. I get negative 729. But what do I know? It can't be negative, right? Because my exponent is even. If your exponent is even, your answer is going to be positive. Some people, when they see these, go, well, there's negatives there. Aren't you supposed to flip it? When is the only reason you flip it when what are negative? Exponents are negative. Only if the exponents. See how neither of the exponents are negative? That's why we're not flipping it. Yes, ma'am?
So you basically just take
Only if it's even. If it's odd, you would put the negative sign there. Because your calculator will not give you the right answer. All right, let's look at C. C says 5 to the 4th power times 5 to the 8th power all over 5 to the 7th power. Aaron, what's the first step I got to do here? Can we subtract right away, or do we have to do something else first with those exponents? What's going on at the top? They're being multiplied, so what are you going to have to do with those exponents? You're going to have to... You don't remember? What do you remember? Start at. You add them. So we get 5 to the 12th over 5 to the 7th. Aaron, what do I do now?
Divide.
And to divide them, we do what to the exponents? Subtract them. That's the new lesson we've been learning today. 5 to the 12th minus the 7th gives us 5 to the 5th. But we can't leave it right there because it's a number. So I take out my calculator and say 5 to the 5th, and I get 3,125. Nice. look at D. Haley, what do I do with D? Now, do you see that I put a 1 over x to the 6th? So if you do that, what do you do first, Haley, after that point? Haley, what's 1 times x to the 6th? What's 1 times x to the 6th? Yep, x to the 6th, or 1x6. What's x to the 4th times 1? X to the 4th. Okay? And what's our new rule, Haley? What am I going to do with those exponents? I'm going to... Yep, so x to the 6th minus x to the 4th gives me what, Haley? 6 minus 4? 2. Can I plug that into my calculator and come up with a number?
No.
Because it's a letter, right? Okay. Okay. All right, so ladies and gentlemen, we're going to go down to the quotient of powers property. Quotient. We will do more. That was just the first ones. Okay, quotients of powers property. Let A and B be real numbers with B not equaling 0, and let M be a positive integer. To find the power of a quotient, find the power of the numerator and the power of the denominator. So look at my example. We've got A over B, both to the M. So we're going to get A to the M over B to the M, as long as B does not equal 0. Okay? So you see how if there is a exponent on the outside of the parentheses, you take that exponent to the top number and to the bottom number. Okay? Yep. So let's do these examples. X over y to the third power would give us x to the third power over y to the third power. Okay? So, CJ, for the one that's in blue, the second one, what would I do? Negative 7 to the what? To the second power. And then I would have, CJ, what would be on the bottom? X to the second power. What is 7 times 7, CJ? That's 7 times 2. What's 7 times 7? Thank you. And what's a negative times a negative, CJ? Positive. So we've got 49 over x squared. Very nice.
Remember, when you have something negative, when you take it to an even numbered exponent, 2, 4, 6, 8, blah, 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 your answer becomes positive. When it's an odd exponent, you know that your number will stay negative.
All right, ladies and gentlemen, we're looking at example 3, which is 4. Please don't talk. We're looking at 4x squared over 5y to the third power. So it's like the distributive property. So we've got a couple steps here. The first one is we're going to take the top, 4x squared to the third power, and we're going to take the same thing to where, Safaria? We get cube to the top. What are we also going to do? Cube the bottom. Cube the bottom. You should be writing this down instead of playing with the whiteboards like I've asked you to. Thank you. Okay, now we're going to distribute the cubed again. We take 4 cubed times x squared cubed. Okay, and we do the same thing with the bottom. 5 cubed y cubed. So 4 times 4 times 4 gives us 64. X squared to the third power, Ty, what does that give us? X squared to the third power. Am I adding or multiplying? So what do I get? 6. 6. X to the 6. All right? So for the bottom, we're getting 5 times 5 times 5, which gives us 125, and we just bring down that y. Okay? So All right, ladies and gentlemen, we're gonna do one more problem.
Two more, actually.
I'm gonna do one more problem, and then Miss Kelvin's gonna do another problem.
This is just like problem 56. So please, somewhere on your paper, put this down. This will help you with 56.
Yes, you have to write this down. You've got plenty of white space at the bottom of your page. Okay, and I don't want to hear any more complaints because this is just like one of the ones from your homework. So I've got 4x cubed y cubed over 2xy, and I'm timesing the whole thing by 5xy squared over 2y. So the first thing I'm going to do, ladies and gentlemen, is I'm going to multiply the tops, multiply the bottoms. So first I look at my whole numbers. 4 times 5 gives me 20. Now I'm looking at just the x's. I've got 3 x's here, but how many x's do I have here? 1, so it gives me x to the 4th. Then I've got 3 y's here and 2 y's here, so I've got y to the 5th. All over 2 times 2 gives me 4. I only have the one x, but how many y's do I have? So it's y squared. Now I'm going to divide. What's 20 divided by 4? 5. And that 5 would go on top because the bigger number's on top. How many? I've got 4 x's here and I've got 1 x here. Remember, you're subtracting because it's division. So 4 minus 1 gives me x to the 3rd. 5 minus 2 gives me y to the 3rd. Because remember, when we're dividing, we subtract. Okay.
We're going to do one more, and it's going to be just like 50, where there's kind of mixed in between.